Welcome to 321 exam. I'll be your mathematics tutor this morning, and we shall be looking at a topic called trigonometry. And one or two things that JAMB is expecting us to know under this topic as a JAMB candidate will be highlighted as follows. The very first one, that you should know the trigonometry ratio of an angle between positive 360 degree to negative 360 degree, which means 360 degree less than or equals to theta less than or equals to minus 360. You should cover everything. The very first one. Then number two, we should quickly look at angles of elevation and depression, and we'll take a look at one or two questions. Bearings, that has to do with positioning, with angle, and every other thing entails, but everything will be centered around cardinal points. That I will introduce you to subsequently. And that we should equally try to look at how to find area of a triangle from a given triangle. Maybe the sides are given plus a particular angle that subtends two sides, or the three sides are given and you are asked to find the area. How would you handle such case? So all this will be looked at as the class progresses. Then finally, we should look at graph of sines and cosine. How do they look like? So that if you see it in exam or anywhere, you should be able to differentiate between the two. That this particular graph is that of sine because it starts from the origin. Then this particular graph is that of cosine because it starts from the maximum value of +1 along the y-axis. But please, I don't want to keep you in suspense. You all look at this in details. And finally, sine and cosine formulae. When do we apply them? Will be looked at. But that will go a long way with the bearings. Now, the very first thing, trigonometry. Trigonometrical ratio of an angles. So let's see. Between positive 360 to minus 360 degree. First and foremost, you need to know that there are different types of triangles. We have the right angle triangle. We have equilateral triangle. We have scaling triangle. We have isosceles triangle. But the very one that we focus our attention to as far as this topic is concerned is that of right angle triangle. The one that you normally see, like this. You always see sine 90, like a box on a particular edge. You know, there are three sides in a triangle. So a particular edge will always have that sign, like an edge. You know, like the way it is indicated here, you can see that. So this implies 90 degree. So in such triangle, you call it right angle triangle. Now the very side where this 90 degree is facing is called hypotenuse, the longest side. This is the longest side. Then your angle of interest, because in every right angle triangle, you must have an angle of interest. This is what I mean by angle of interest. Assuming I decide to put my angle of interest to be here, theta, where theta is. You know, theta is now facing down. So the particular side that is directly opposite angle of interest is taken to be opposite side, this one. Then remaining one side now. That last side is called the adjacent. So please take note of this illustration. It is key. Very, very important. Please. And that is what is indicated here all through. The hypotenuse, the opposite. Opposite is here because the angle of interest is here. In the other diagram that you can see. Okay? So this is the adjacent. So what this implies is the angle of interest goes a long way in helping you locating the opposite side. Because as soon as you change the angle of interest, from one particular edge of the triangle to another side, then we expect the opposite side to equally change simultaneously. Because you can see the diagram before you, this one, the angle of interest is here. So the opposite side is here, so opposite is here. The one I sketched, look at the angle of interest and see the side opposite. So the 90 degree, that particular side where it is pointing to is the hypotenuse. So it is always very easy to locate the hypotenuse than the last side adjacent. Now, let's quickly look at this abbreviation, very popular one, SOHCAHTOA. SOHCAHTOA. What does this help us to attain? It tells us that the three trigonometric functions are 1, look at it, 1, S, standing for sine, 2, cos, standing as C, cosine, 3, T, which is tan, standing as T in the abbreviation, you can see it, then tan, gens. There are 3 important trigonometric ratios or trigonometric functions. 1, sine, 2, cosine, 3, tangent. Take note of this, please. And that to get sine in a given right angle triangle, all you need to check is opposite over hypotenuse. If you know your opposite, you know hypotenuse. If you divide these two, you will get your sine theta. As for the cos, you look at your adjacent with respect to the hypotenuse side, which is adjacent over hypotenuse, as indicated in the abbreviation, please. Okay? So now to get the tan theta, it will be opposite relating with the adjacent, which is opposite over adjacent, equal to tan theta. Please take note of that very, very quickly. Then trigonometric ratios of special angles. You need to know this. You know the special angles, there are so many. But by your scheme, that we should look at the 30 degree, the 45 degree, and the 60 degree. Please, I will advise that we equally have 0 degree, 90 degree included. You can know it in case. So for 45 degree, you see the right angle triangle drawn. Here is 45. This one is 90. Then here is 1, here is 1. Then automatically, using Pythagoras theory, the longest side becomes root 2. So if I need to find sine 45, for example, sine 45, it will be opposite. Here is now opposite because the angle of interest 45 is facing the other side. Opposite. This one adjacent. This is the hypotenuse. Okay? So sine 45, it will be opposite over hypotenuse, which is opposite over hypotenuse is 1 over root 2. Then cos 45. It's also adjacent over hypotenuse, which is 1 over root 2. Then tan 45 is 1 over 1, which is 1. Please, I have to say this. If you watch very clearly, you will see that sine 45 is equals to cos 45, which is equals to 1 over root 2. Now, I have seen in the past JAMB question paper where they ask the students that at what angle will sine theta equal to cos theta between 360 to minus 360 degree? At what angle? Don't be deceived. It is this angle, angle 45 degree. You can see it. And now, if it were to be in radian, there's a clear conversion between degree and radian. 1 pi is equivalent to 180 degree. Please take note. 1 pi in rad is equivalent to 180 degree. So now, I have 45 degree. What will be its equivalent in radian? So it will be 45 degree. The equivalent of it, I don't know. Let's say x. So invariably, x becomes 45. X becomes 45 over 180. So 45, 5 can go now. Or 9. 9 here, 5. 9 here, 20. 5 here, 1. 5 here, 4. It means 45 degree is equivalent to pi over 4 in radian. Take note of this. So at what angle is sine theta equals to cos theta? Between the range of 360 degree to minus 360 degree. So you say 45 degree. Angle 45 degree. The one that lies in the first quadrant. Because as it changes, you know, there are 4 quadrants now. So first quadrant, second quadrant, third, fourth. So at you move from first quadrant to the second quadrant, the signs, the three important trigonometry ratios change. They change with respect to the signs. So what am I saying? That some will be negative, some will be positive. You will see all of this as the class progresses. But for now, note that in the first quadrant, it is the only quadrant where the sine, the cos, and the tan are all positive. Now, angle 30 and 60 degree, this is supposed to be called equilateral triangle, where all the sides as well as the three angles are equal. Equilateral triangle, I said. So, if the three angles are equal, it means 60, 60, 60. Then this one, because of it is bisect, you can see the bisection line. So 30 degree here, then 30 degree here. Okay? So now with 30 degree, here is 2, here is 2, here is 1, here is 1. So that, 1 plus 1 will still be 2, the whole length. Let's say A, B, C. So now, I want to find 30 degree. For example, sine 30, sine is already opposite over hypotenuse. Now I'm using 30. This one becomes angle of interest. So here is opposite. So it will be 1 all over 2. But remember, this one in the middle is root 3. You can use Pythagoras theory to always get that. It is not a case at all. So now cos 30 is adjacent all over hypotenuse. Where is the adjacent? This one becomes the adjacent, root 3. So it will be root 3 over 2. Then tan 30 becomes what? Tan 30, opposite all over adjacent. It will be 1 all over root 3. So you take note of that. That is for the 30 degree. Now for 60 degree, here 60 degree, this one is 2, here is root 3, this is 1, 90 is here. 90 is here, meaning hypotenuse side is here. Then here is opposite. This one is adjacent. Okay, so sine 60 is opposite all over hypotenuse, which is root 3 over 2. Then cos 60 is adjacent all over hypotenuse, which is 1 over 2. Then tan 60 is opposite all over adjacent, which is equals to root 3 over 1. Tan 60 degree. You don't need stress. They are called special angles. First quadrant, let's look at it. Look at first quadrant. Look at what is happening in first quadrant. This is positive y-axis. This is positive x-axis. Okay? So here is the line that we will take to be the resultant between the x and the y-axis. So let's look at it. And if I take the resultant to be r, and that r to be 1 unit, it doesn't change anything. Take note, it doesn't change anything at all. So here is positive y, this is positive x. Okay? So here is the theta. Now, sine theta here, sine theta is equals to what? Is equals to opposite. Here it becomes opposite now. Angle of interest is here, adjacent hypotenuse. Okay. Now, sine theta is equals to opposite all over, which is plus y over 1. It means it is plus y. Okay? Plus y divided by 1 plus y. But invariably, from first quadrant, there's a very genuine relationship that we need to know. That relationship is that sine theta can be converted to cos theta with the help of this. 90 minus theta, or cos theta is equals to sine theta, open bracket 90 minus theta. So please, you take note of this. Please, take note of this. That sine theta is equals to cos, open bracket 90 minus theta, and that cos theta can be changed to sine by using 90 minus theta, the same relationship that it is stated as follows. Okay, not only that, note that sine theta is positive, cos theta is positive, tan theta is positive. The three trigonometric ratios in the first quadrant, this is first quadrant, are all positive. Techniques will come to an end. I'll see you for the continuation of this topic in the next lesson. Thank you.